My name is Randy. I work for Blockstream. This is getting started with Greenlight, this whole workshop. And before I wanted to get into the specifics and details, I just kind of wanted to give an overview of what Greenlight was and what the Lightning Network is for anyone familiar with that. So yeah, getting started with Greenlight. So here's some background for all of you. So what's the Lightning Network? A lot of you already kind of know what the Lightning Network is, right? It's off-chain protocol for being able to pay other people. And yeah, it's a network of peer-to-peer connections that facilitates off-chain exchange of Bitcoin transactions. So yeah, sorry, I'm just trying to modulate the correct level. So yeah, we all know what the Lightning Network is. It's a off-chain computation where you can pay other people, and that has a couple advantages. One of the advantages being that you get near instant payments. There's no confirmations needed, like once post-channel creation. So once you have your channel, you could pay someone instantly. Advantage of Lightning. There's low fees, so it's lower than on-chain. And but there are some drawbacks to Lightning. One of these things being liquidity management, which has been a hot topic in the Bitcoin community recently. If you've kept track of all the recent developments, you might have heard of ARC, which is something that aims to solve things like liquidity. But another one is interactivity requirements, right? You have to be online almost all the time. And that means you kind of need a watchtower and you need a signer to always be available. Because whenever you send or you receive payments, you kind of have to settle up, right? So you kind of need this signer to create an update transaction whenever a state change occurs. So these are some of the drawbacks of the Lightning Network, that it's not completely, it's not like off-chain. I mean, it's not, you can't have cold storage funds. Your signer always has to be hot to receive and send money. And sometimes managing the signer in the watchtower can be a challenge for some. So Greenlight is something that's supposed to relieve some of this hosting. There are a couple different Lightning node implementations. I kind of put the most popular on here. There's Core Lightning, there's LND, and there's Eclair, and they're all very popular implementations. And some people ask why Core Lightning for Greenlight. Well, that's a very modular architecture. So if you've ever used it, it's very easy to use like plugins, and you could kind of extend it with all this functionality. It's also maintained by the Greenlight project lead, which is Christian Decker. It's and of course, like Rusty is internal to the company. He's another maintainer for Core Lightning, so it kind of makes sense to build, of course, Greenlight on Core Lightning. So all of this is about hosting all of that. And yeah, there's a link here in case you guys want to go and see more information about Greenlight. So what is Greenlight? Because a lot of people have misconceptions about what Greenlight can and can't do, because they don't really understand what Greenlight does as a fundamental level. And what is Greenlight? So Greenlight, it's a non-custodial cloud offering for Core Lightning. That's the best description I can make. It takes away the maintaining Bitcoin and Lightning nodes while allowing you to be in full control of your keys. I made this catchphrase that we bring the cloud and you make the Lightning. So you get to keep all your keys on your devices. We never need your keys. So if any support person calls you while using Greenlight, they're probably trying to scam you because we just need your signatures for things. We maintain everything else. So the Core Lightning node, the watchtower that is maintained by us, it's cloud infrastructure for Lightning, and it's different from all these other offerings. People say, how's it different from Voltage or whatever other cloud provider? Because we are completely non-custodial. We are completely non-custodial. So we will never have your keys encrypted or otherwise. So I also put some more reasons of how Greenlight differs from other cloud solutions. We have on-demand nodes. So the nodes that we run actually turn off like when you're not using it, and that kind of helps us run our infrastructure a little bit better. Hello? Okay. It helps us run infrastructure a little bit better by not having to keep your nodes on all the time. And it makes it more scalable, of course, because we can support a higher number of users.
Check.
Okay. Thanks. Yeah, we could help. Yeah, we can support a higher number of users once we can, turn down these nodes. Also, when we're thinking about the cost to a developer, it's a lot cheaper to run for you as a developer. That means we don't have to price you as much as some of these other cloud offerings because these nodes can turn off. They're not on all the time. So it's just an efficient way to run things. And you typically don't need your node on all the time. If we have shared infrastructure for your Bitcoin data, because we do have a Bitcoin data provider for all of our Lightning nodes. We have an implementation of a rapid gossip sync, so all of your nodes can sync up pretty quick with the gossip network. So it just kind of makes sense to have this model. It's also non-custodial. As I said before, there's zero risk of signing key theft from our servers because we will never have your keys. I want to emphasize that because a lot of people are not quite sure of that aspect. And I'll kind of get into a little bit of how we do this as well. So one of the most important things about Greenlight is we don't want any vendor lock-in. So offboarding, it was an essential in making this project. So if any customer who would like to use Greenlight as a starting point and export their state from the Lightning node has the option to do that and create their core Lightning node off their data that they've used from Greenlight. So we have customers who approach us who have long-term goals of self-hosting, but who would like to start off on Greenlight. But of course, if they wanted to scale to a larger form operation, let's say a la Breeze, then we also support that. So core Lightning architecture. This is a tweet. Has a little typo in the tweet, but yeah, I kept it the same. C Lightning is a collection of daemons that talk to one another via file descriptors. Unix is the only ask blah blah blah. It had some other stuff I cut off. But yeah, if you guys have never worked with core Lightning, it's kind of like a collection of services within. So there's a whole bunch of these daemons that run, and that is a core part of understanding how the Greenlight works, because what the HSMD subdaemon was able to do for us is that because all of the cryptographic signing operations are delegated to this subdaemon, we were able to make our own implementation and use the same file descriptor that messages would pass through. So we kind of made our own implementation of HSMD. We kind of called this the signer proxy. And it helps pretty much usher data from your node on our infrastructure to your signer on whatever device you choose, whether it's your phone or your laptop somewhere else. And I kind of have this little diagram here. So these green things are binaries that we have running. And this gray box, HSMD, was the subdaemon that was there before. We pretty much don't use it. And instead we have this socket or the file descriptor giving information to our HSM proxy. And that's helping push certain data to a Greenlight signer. There's something in the middle, but not really relevant. But all this is on our GitHub as well, so you could take a look at it. But this is kind of the general architecture. That's a diagram I made. And of course, we have this Greenlight signer that is powered by VLS, which I'll also get into a little bit. So some more Greenlight basics. Authentication. So Greenlight uses TLS-based authentication and has two types of certificates. So we have these partner/developer certificates. These are the certificates that someone like Breeze would get. This type of certificate allows you to register the nodes. So if I'm a developer and I want to make a Lightning wallet, then you go on our website, you download these partner/developer certificates, and using this is how you issue en masse all the Lightning nodes that your users would need. And they're also used for recovering Greenlight nodes, if something happened to it. Because once you register a Lightning node on Greenlight, you get something called device credentials, and that's where the second part comes in, device certificates. These certificates are used to interact with your Greenlight nodes. So if you wanted to make a get info call to your core Lightning node that's hosted on Greenlight, the authentication mechanism that you'd have to use is your device certificate. So Breeze kind of manages all these. I use Breeze as an example because they're one of the biggest consumers of Greenlight. But they have Breeze has device certificates that for every single user, and again, that's how they talk to each of these users' nodes. So the scheduler. The scheduler is also another important part of Greenlight because it's the thing that you actually call to register your node using your developer/partner certificates. And what I have here is the scheduler. Scheduler is the component of Greenlight responsible for handling requests related to the management of your Lightning nodes. So scheduler isn't actually doing anything as part of the operation of your Lightning node. It's helping manage the infrastructure of your Lightning node itself. So, and you'll see on the GitHub page after. But during node registration, the scheduler authenticates registration requests from signers, and it responds with the certificates needed to schedule the newly registered nodes associated with those signers. So again, those are like the device certificates I was talking about. So far the flow when you start with Greenlight is you download our developer certificates from our page, and then you go and you talk to the scheduler to register a node, and they will give you device certs, and the device certs are what allow you to talk to your node. Using the device certs, you can make any calls to your Lightning node, except ones that require a signer, because the ones that require a signer require you to connect a signer, and that's a part I'll get to after this slide. And then I said because nodes are shut down when inactive, the process of scheduling is a way for us to turn your node back on. So scheduling your node can be done in an automatic way. When you call certain methods on our SDK, it'll automatically schedule for you. But if you want to be more cognizant of how long your nodes are up and when they're scheduled and all of that information, you can also do that yourself. So we try and make it simple for people, but we also want to give people options. So if they wanted to be able to control when the nodes go up and down, that's also an option for them. Yeah, okay. So VLS. A lot of people hear VLS and they also don't know what that is. They don't know how it's associated with our project Greenlight. VLS is not a GLS is not a blockstream maintained project. It is a third-party library that we use, of course, and it's being used by a lot of Lightning projects in the ecosystem. VLS is a signer. It's a signer implementation, but it comes with a lot of validation with respect to what is being signed, and it has state associated with this library as well once you start running it. And what I have here is VLS is a library used for signing. It can be used to replace the signing operations typically handled within HSMD. So again, remembering back to the architecture that I was kind of giving a high-level overview of, HSMD is one of these subdaemons responsible for signing. So VLS is that component that will replace the signing functionality in core Lightning. So VLS, that library is incorporated within the signer that is going to be on your device. So I'd like to give a recap. I don't want to lose anyone. So on the core Lightning node, on our infrastructure, instead of talking to the HSMD subdaemon that would naturally be there, it talks to a proxy. That proxy sends information to a signer on the user's device, and the signer on the user's device will sign what we call HSM requests using the VLS library. So that's how it all comes together so far. So Greenlight's VLS-based client signer. So Greenlight uses VLS in the signer to generate the responses core Lightning would expect from the built-in HSMD. The signer configures policies on VLS and adds values to the VLS handler state for the policies to validate against. So you can configure policies on VLS. You can make it as permissive as you want. You can make it as restrictive as you want. Certain things that it prevents against is, let's say if I was opening a channel and I wanted to change the close to address, you have to configure your VLS signer in a way such that it understands that, hey, I'm going to send you a message from core Lightning that you're going to need a sign that involves setting the close to address on this channel creation. So you kind of have to warn VLS about certain things before it receives messages to sign. So you have to configure it in a certain way. And that's what I mean by policies. So hopefully you can kind of imagine more generalized policies. But the close to address is one thing I recently worked on. So, and lastly, the signer contains the logic needed to connect to the Greenlight server. So HSMD bound requests from core Lightning can be marshaled to and from the signer. So our SDK, I can go over kind of the high level of what we have here. So we have our Rust client. Our Rust client you can kind of pull directly from the GitHub repo. A lot of people like to using straight from the main branch, or they'll use a specific commit, so it doesn't break. But the Greenlight client that's most actively maintained is, of course, our Rust client. Everything else is a binding associated with that Rust client. So it's within the GL client folder on the Greenlight repository. That's where all our changes are made first. And the second thing that we maintain is our Python SDK. Python SDK, we try and actively maintain it, but of course sometimes it kind of gets out of date. I originally had a workshop that I wanted to do stuff with the Python SDK on, but it's not as maintained as the newest, so I decided not to go with it. But yeah, we make bindings with a tool called Maturin that you can look up, and it's also on our repo. Um, and then of course there's the Breeze SDK, which we recommend all mobile developers to use. We do not have any bindings for like any mobile platform, so nothing for Android, nothing for iOS. But luckily, Breeze has taken our library and made their own SDK. So when you use Breeze's SDK, you end up using Greenlight kind of in in the internals. Because the Breeze SDK is what we encourage mobile developers. It works out of the box for Android and iOS apps, and it's what's used in Breeze. So aside from the Greenlight code we expose to our SDK, the Breeze SDK also includes functions that allow you to communicate with the LSP. Because having a node is one thing, being able to create channels and payments is another thing, and having a nice LSP packaged into your library or SDK is a very helpful thing. So if you wanted to kind of have LSP support within within the SDK that you're using for Greenlight, then I'd recommend using the Breeze SDK. So our development environment. Our development environment is still in early stages, so for developers it's not super friendly, to be honest. We have something called GL testing, which is a dev environment that we have to allow developers who want to build on Greenlight to be able to test against this rather than test against mainnet, because no one wants to lose real funds when they're trying out a new SDK or a new idea. So we have this thing called GL testing, and within our repo we have like a Docker files and make files that allow you to make a Docker image and make our Docker shell that's configured with GL testing. And essentially it's a collection of services that mock the behavior of the Greenlight backend. So GL testing, it enables developers to test their Greenlight code against a reg test deployment. So you can make blocks as fast as you want, you can make as many coins as you want, and it's instead of programming everything against mainnet. So going back, I was talking about something called a scheduler, and for people who want to test against a scheduler and make some feature changes against it, you can go into the repo and you can look at the async scheduler. And the async scheduler, it's just a drop-in replacement for the scheduler in the Greenlight backend and is used to test calls against the scheduler. And the async scheduler is written in Python, and it aims to mimic the behavior of the scheduler used in the Greenlight backend pretty much one-to-one. So again, this is used as a testing environment, so we try and keep that parity as close as we can. In fact, all of our tests are done using GL testing. So everything, we have some unit tests, but most of our tests actually run through the Python SDK to force us to keep the Python SDK in parity with our Rust SDK. We also have this thing called client, and I'll show you that too in the code later. The client is a class in GL testing. It's used to return objects defined within the GL client for use with the async scheduler. If spun up. Using the client, we can initialize a signer, a node, and a TLS config. Again, things that I'll go into more a little bit later when we look at the code. So, and then I just wanted to go to future work before looking at some of the code. Thank you.
Hold on, it's muted, and there you go.
Oh. Yeah. Hello? Okay, awesome.
There's a switch on it.
So yeah, future work. Before I wanted to get into more of the deep dives of the code, I wanted to go into future work. So right now we're working on webhooks. So there are some events that would be helpful for Greenlight consumers to get notified of. And I have an example here. For example, anytime a node registered by a developer needs a signer to come online to receive a payment, we, as Greenlight, should be able to tell whatever developer, like wallet developer like Breeze, that hey, you're getting a payment and you need your signer to go online, whatever your user signers. And we can get certain information like that because we install certain plugins on users node to be able to monitor certain pieces of information. Right now, the way Breeze works is they have the LSP, and when they receive a payment for one of their users, they know to hey, we're gonna send a push notification to this user to say hey, come online, so that because once your app is actually active, they will connect your signer to our Greenlight servers, and then they can finish receiving this payment. But how about if Breeze decided to expand the offering to other LSPs, and they wanted their users to be able to use any LSP they want, then they no longer get this functionality of being able to tell their user to come online because they wouldn't know when they're getting payments. So Greenlight has we're doing these webhooks for those type of events. We're leveraging HTTP, which are pretty standard for webhooks. the first type of event that will be sent with this mechanism is for something called stuck nodes. So nodes, sometimes it requires a signer to be online, and a signer might disconnect for whatever reason, their phone dies, or whoever knows or what thing could happen. And your node will get into the state where we can no longer keep it synced with like our gossip store and other information, and we kind of need the signer to come back online. So this is an active problem with Breeze, and they can kind of detect if a node hasn't been active for too long, like maybe we should ping a user just to make sure they come on the app. But yeah, developers should know when they have stuck nodes. Or one of the users' phone died during a signing operation and halted their node from syncing with the rest of the gossip store. Yeah. Runes is something else. Runes is something a lot of people in Lightning know. So runes and core lightnings are like tokens. They're created for accessing the Lightning node from external clients in a permission fashion. So runes and Greenlight are an extension of this concept, and they're used as a form of permission device certificates, pretty much. And a simple use case to think of is, let's say we have a developer, and the developer would like to give an external service the ability to get the balance of their Lightning nodes. Why? Because maybe the external service occasionally queries the balance to rebalance their Greenlight nodes for them. In which case, you'd want this external service to have access to some of your developers' nodes. So that's what these runes are for. They're in development right now, and they'll enable some really cool stuff once we couple them with webhooks. One of them being, Lightning addresses, which are pretty popular, and we wanted to be able to support anything our users would like to use. Plugins. Plugins are an interesting topic for Greenlight because, again, we host people's core Lightning nodes. We don't want them running any arbitrary code on our servers, right? They can essentially give us like malware. So we have to think through how we'd want to enable plugins in this cloud-hosted environment. So with hosted nodes, we have the added challenge of figuring out how to do this. But the development of this feature is still in its early stages. We have some big users who have interesting ideas of how they would like to implement plugins and integrate with our environments. And the idea is to funnel information to and from an external service that's hosted by the developer. So if Breeze wanted to have a plugin, then they'd go and host some service that connects to our Greenlight servers, and we'd marshal data to and from this external service. And we'd essentially have a remote plugin, like we have a remote signer. So workshop. So I wanted to kind of put some of these ideas together. It's not going to be a super in-depth workshop. It's going to be actually pretty quick. Because I didn't want to actually make any channels, but the Greenlight developer console is where everything starts out. So before we begin programming, and I'll go through all this so you can actually see. Before we begin programming, we navigate to this website, greenlight.blockstream.com. Very easy to remember and all of that. And I think I had it open. Maybe not. Greenlight.blockstream.com. And just sign in with Google because it's quickest. And we don't have much on our developer console. We're actually gonna have a lot more on it probably by next month. But right now you could download what we call the partner certificate / developer certificate. And it essentially just gives you a zip file called GL certs. And this GL certs, if you open it up, it actually has a client key and it has a client cert. And both of these are used for again, registering nodes, because partner / developer certificates are used to register nodes for your users. So after we have these two, let's go back to our slides so we could, because I kind of detail this process. So yeah, you create an account. I already had an account. I logged in with Google. It made it very ezy. Then you verify your email address. If you did it logged in with Google, you don't need to do that. And then you go into the developer console. And then I kind of showed you this page, and it didn't have much to it, just one button and a link to the documentation. And using that download button, you download the certs. Again, these are partner / developer certs that you'd use to register a node. And then finally, you'd get to actually registering a node. But before you register a node, you have to make a seed phrase, right? So VLS, it will take the seed that you use, but you could generate the seed however you want. Of course, this is just a quick way to generate a seed. I used Python here. Yeah, I think you guys could see it okay. So I used BIP39. I made some random bits. I encoded the bytes, blah, blah. And then I made a seed phrase. Then you save it to a file that you could access easily. Then after you do that, this is, again, the extension of the Python code. So this is when actually registering a node. After you've made your seed, you can go ahead and load up your seed. You could decode the phrase into bytes, and then you could open your developer cert and your developer key. So again, these are the things that we downloaded. These are our partner/developer certs. And then we initialize the TLS config. So you talk to our Greenlight servers using TLS, and you need to initialize like this TLS connection using the certs that you downloaded off our website. So you'll do TLS config.identity, and then you can put in the developer cert and developer key that you read in. Again, those derive from what you downloaded on the website, and then you create a signer. Now the signer is essentially, it's a housing for a VLS. And these are all Rust bindings, so it's almost strictly VLS with some nice syntactic sugar that we added with Greenlight. Specify the network. Right now we support the mainnet and testnet. Testnet is kind of unreliable. Blocks don't always come every 10 minutes. So you could use, some people feel like they're forced to use mainnet, but we have been looking into having other networks supported, such as Signet or even better, Mutiny Signet, which I hear has great developer support. And then you make our scheduler object. So this is a scheduler client. This is what we use to talk to our scheduler to register our nodes. You give it a node ID, which your signer has because it has your private key, your seed. And you give it the network and the TLS, and then finally you can register your node. So developer, I might have forgotten the register call there, but after you do that, there's like scheduler.register that I don't think I have. When you do call that register, you get a response, and the response has it's like kind of like a JSON response, and it has two fields to it. One is like the certificate, a device certificate, and one's the device key. And the device certificate you could save as is from the response into device.crt. And you could save the device key, that's a response.register node call, straight to device-key.pem. And then using the device cert and the device key, you initialize a new TLS identity that's separate from the one that you use to register your node. And then you make your signer again, and then finally you can get access to your node by calling scheduler.node. And then you could start printing calls for your node, like node.getInfo. And that's pretty much the end of this. I wanted to show a live demo that was on this laptop. The display wasn't working too well earlier. I'm gonna try it again. It's gonna be quick, and I'm gonna finish. I did this one in Rust, so I just wanted to show you how some of the actual code looks like there. Bear with me 1 second. So this is how it would look. Just as an example, this has all my directories. This is a sample seed. I just called it S. But so this is what you do after you've registered your node and you were given device certificates to talk to your node with. You'd get some random seed, and then you'd load up your device certificates from somewhere on your computer. And again, these device certificates are returned the response after you register your node. You create a TLS config using the device cert and the device key. Everything is unwrapped here, very unsafe, but very easy to use. And then you can create a signer using this seed. Again, S had the seed. I just called hex the code to get the bytes. I specified the network as Bitcoin. I used the TLS config. And then I made the scheduler. The scheduler takes in the signer, so it knows which node to actually spin up. And then using the scheduler, I schedule my node. And again, you have to pass this TLS config. And once you have your node, after scheduling it, you could do whatever you want with it. So I just called get info, and then I just printed the node info response. And I could run it again, just so you could see it. But pretty much this code gets executed. It initializes a signer, a scheduler that accepts the signer to know which node to talk to, and then I call schedule on the scheduler to get a node reference that I can make a get info call to. And then you see kind of like get info here. And there's many other, this is using the Core Lightning gRPC interface. So if you guys have ever poked around the Core Lightning library, or the libraries that it uses and all the internals of Core Lightning on the repo, you will see that there's a gRPC interface that allows you to make a lot of the calls that you'd need for a Core Lightning node. So Greenlight, we're aiming to support all of those gRPC calls. So anything you could think of to call straight to your Lightning node, you can call to Greenlight. And yeah, that's pretty much the end of my presentation. So thank you all. Yeah.